Okay, we are going to talk about complex numbers. Complex numbers we imagine as a format Z. Use red color. Z that is equal A plus B I, where A is a real part, B I is imaginary part. Okay. And I itself is imaginary number. I is equal square root of -1. Therefore, I squared is equal -1. So as you can see, imaginary number is taking care of square root where we have negative numbers stuck under, right? That's for radicals with square root and negative number underneath. All right, the question is, you might ask, why do we need to know and where do we use? Imaginary numbers we use in quadratic equations, in advanced calculus, which means if we use in calculus, that means it's used in engineering. Specifically, it's used in electrical circuits, because the electricity, it's like a type of science or cosine form, right? And that's where it's heavily used, imaginary number. Do not try to imagine in life how an imaginary number it looks like, because it's you kind of will be in the 3D space, you will look the fourth dimension in there. So just take it that in math we use sometimes imaginary numbers in the whole expression a plus bi we call complex number. Okay, let's start doing some the operations. Before I start solving problems, which I'm going to solve a bunch of them, I want you to know, just like any number, if we have I to power 0, there is no exception. How much is it? 1, of course. If we have I to power 1, no exception also, is I. Now, getting to I to power 2, here what we have is equal -1. Okay, let's take I to power 3. That is equal, I can put as I squared times I, right? Because I is degree 1, I squared degree 2, 2 plus 1 is 3. We add exponent when we multiply numbers with exponent, yes? So that is going to be equal, I squared is equal -1, yes? And we multiply by I, we are going to get -I. Okay? Next, I to 4. Is equal, I can break down I squared times I squared. Since we know that I squared is -1, we are trying to go through I squared everything. I squared times I squared. So I squared is -1. Another I squared is -1. So we are going to get +1. I to 5 is equal I to 4 times I, correct? Why did we use I to 4? Because we know that I to 4 is 1, right here. Yes? Therefore, we are going to have 1 times I. It's going to be I. And so on. I can use I to 6. It's going to be I to 5 times I. I to 6, I to 5 is equal I. And then times another I. It's going to be I squared, and it's going to be negative 1. Okay, let's do I to 7, and we can stop there. I to 7 is equal. I to 6 is negative 1, and we type I, and we're going to get negative I. Later on, I will show you, without going through all this bunch of notations, how to figure out higher degree. What if you need I to power 49? You are not going to raise from 0 to all the way to 48 and then times I, right? I will show you how to work with such numbers we will have in our problems. Okay, let's start working on complex numbers. Question number 1. We have square root negative 100. What does that mean? That means we do it's equal. We do negative 1 times 100, right? Which is equal square root negative 1 times square root of 100, right? Square root of 100 is 10, and the square root of negative I, see here? Okay, I'll write down here, so we have I is equal square root of negative 1, and I squared is equal negative 1. I'll write down here, so we have in front of us. So which means we are going to get 10 I, because square root of negative 1 is going to be I. Okay, next one. Square root of negative 3. So I'm going to write down negative 1 times times 3. Since square root 3 doesn't give me anything, so from negative 1, square root negative 1, we get I and square root 3. Number 3. Negative square root of 49. As you can see, this negative stands outside. It has nothing to do with square root negative, right? So square root 49 is 7. We get negative 7. This is tricky part, so you have to be careful. Negative, number 4, square root negative 16. Is equal. So again, negative 1 times square root 16. That's going to be square root 16 is 4, and square root I, negative 1 is I. All right, now let's do more interesting cases. Square root of negative 28. Okay, what do I get? Negative 1 right away times 7 times 4, right? 28. I broke down into 2 terms, 7 and 4. With the purpose, so I can partially take out of square root. So what's going to happen? Square root of 4, I'm getting 2, which is this one, right? I take square root of 4, it's 2. And square root of negative 1, it's going to be I, right? And 7 got stuck under square root. So it's going to stay there. Next one. Negative and negative 9. We are getting negative. So negative 9, it's going to be what? 3i, correct? Because we have negative, that means I will come out from this negative, and square root 9 is 3. Okay, next one. Number 7. 8 square root negative 8. Okay, so 8 times square root negative 1. 8, I'm breaking down 4 and 2, right? All right, square root of 4. Okay, 8 times square root of 4 is 2. Square root of negative 1 is I, and square root 2 gets stuck under square root. So we get 16i square root 2. Okay. Question number 8. Square root of negative 17 times square root of 19. Negative 19. Well, there is no square root from 17. There is no square root from 19. What we can do in this case? There is only one thing. Negative square root of, I cannot, and we do not dare, take square root negative 17, directly multiply by negative square root negative 19. First, we need to get this negative sign out, which is going to be I square root 17 times I square root 19. And we are going to get I squared square root of 17 times 19, 323. And the square root of I squared is equal negative 1, yes? Therefore, it's going to be negative square root 323. So be careful when you multiply two negatives with square root negative. All right, one more. So square root negative 3 times square root negative 21. It's equal. So I square root 3 times I square root 21. And what we are going to get? I squared square root of 63. Now, what is interesting here? 63 I can break down into 9 and 7, right? So square root of, I squared is negative. Square root of 9, it's going to be 3. Yes. And square root of 7 gets stuck underneath. Let me make it look better so you can understand. There we go. Question number 10. Now we have one positive, one negative under square root. Let's see what's going to happen with this one. Square root 81 times square root of negative 1. Square root of 81 is 9. Square root of negative 1 is I. And we get the answer. Okay, let's try division now. Question number 11. We have square root negative 130 over square root of 10. Okay? How much it's going to be? So since we cannot have the square root in denominator, we need to rationalize Yes? Or put under square root. Let's try to put under square root since see what it's going to happen. So first of all, I'm taking out square root of negative 130. It's going to be I 130 and square root of 10. So based on properties of square root or radicals, we have square root a over square root b is equal square root a over b. Yes? Therefore, we are going to put these both square roots under one umbrella. So I, and we get square root 130 over 10. So we get rid of this square root. We get rid of a square root in denominator. So we can cancel this 10 with this 0. And we are getting I square root 13. Okay? Next one. Question number 12. We have square root of negative 54 over square root of negative 2. Okay, let's get out this I first. Here we have I square root of 54. And here we get I square root of 2. So what do? We can cancel these i's. I here, we cancel. And we get square root 54 over 2. Based on this property, yes? So square root 54 over 2, it's going to be 27. Square root 27. So 27 I break down into square root of 9 and square root of 3, right? 9 times 3. So square root of 9 is 3, and we get underneath 3. Okay? Let's do addition subtraction. Number 13. We have 6 minus 8i plus 6 plus 6i. All right, combining like terms. 6 with 6, negative 8i with 6i. And we are getting 12 minus 2i. One more. 8 plus 4i minus, since I have minus in front of parentheses, then I'll put parentheses. 9 minus 4i. So that is equal 8 plus 4i, obviously minus 9, and plus 4i, yes? Like terms, 8 with negative 9, 4i and another 4i, and we are getting negative 1 plus 8i. All right. Next one. What do we have? Negative 10i times negative 3i. How much it's going to be? First of all, negative times negative. It's going to be positive, right? This negative, I mean. This negative and this negative. It's going to be positive. And then I times I, it's going to be I squared. And 10 times 3, it's going to be 30. Since I squared is equal negative 1, we get negative 30. That was a good one. And one more. 16. So 6i times 4 minus 9i. And it's equal, 6i times 4 is 24i, and 6i times negative 9i, it's gonna be negative 54i squared, right? Here. Negative 54i squared, which means we get a 54i squared, I squared is negative, so we get positive 54, right? And 24i stays the way it is. All right? We are good. Question number 17. Square root 2 plus 3i square 2 minus 3i. Okay, what do we have here? It's looks like we have a plus b times a minus b, right? Does it remind you? Difference of squares? So let me remind you here formula. A plus b times a minus b is equal a squared minus b squared. And we have square root 2 squared minus 3i squared. So as a result, we are getting square root 2 squared, it's 2 comes out, right? Because square root 2 times square root 2, it's going to be square root 4, and 2 comes out. Okay? And 3i squared, it's going to be minus 3 squared is 9, I squared is I squared. So as a result, we get, since I squared is negative, we get 2 plus 9 equal 11. So complex number, it's not the expression, it's a number. If you do some operation, you will end up with number. So 2 plus 9 equal 11. Next one, question number 18. We have 3 minus 5i squared. That is equal. So 3 minus 5i squared, there is formula for that. A minus b squared. Remember? Perfect square. A squared minus 2ab plus b squared. So we get a squared, which is going to be, this is my a, this is my b. So a squared is going to be 3 squared. And then minus 2 times a, meaning times 3, and b will be 5i. And plus b squared, b is 5i, we raise to power 2. So as a result, we get 9 minus 2 times 3 is 6, 6 times 5 is 30, and I, 30i. And plus 5i squared. So 5 squared is 25. I squared is negative 1. Therefore, this plus will become minus. Let me make this plus better seen. Okay. So from here, we are getting 9 minus 25. It's going to be negative 16 and minus 30i. All right. Next, let's do division with I. 3 over I. How we gonna work out such type? So, because we cannot have negative sign, we cannot have I, imaginary number, in denominator, we are going to get rid of it. How I can get rid of that one? So, I'm going to multiply by I, numerator and denominator, right? Because I times I is I squared, and this way I get rid of I, correct? Okay, 3 over I, let's multiply by I here, denominator, and the same thing we have to do to numerator. And what do we get? We are getting here 3I, here we get I squared, and 3I over negative 1, which is equal negative 3I. Okay, question number 20. Eight over 5 plus 4I. Okay, remember what we said, we cannot tolerate having imaginary number in denominator. So, and I cannot multiply by I because it's tied up with addition. Therefore, the only way to get rid of this I, I'm going to apply formula. If I have A plus B, I have to multiply by A minus B. And this way I will get squared of A minus square of B, right? Therefore, here I'm going to 5 plus 4I. So I'm going to multiply by 5 minus 4I. And whatever change I did to denominator, I'm going to do to numerator. So what do I get here? In denominator, I'm getting 5 squared, right? Minus 4I squared. In numerator, let's distribute. It's going to be 8 times 5 is 40. Minus 8 times 4I, it's going to be negative 32I. Now let's work out denominator. It's going to be 5 squared is 25. Now minus 4 squared is 16. I squared is negative 1, which means it's going to be positive 16, right? With this negative 1 will be positive. So we get 40 minus 32I. Did we get rid of I? Yes, we did. So to write down in the format of the complex number, and the format of complex number is A plus BI is going to be equal 40 over 25 plus 16, it's going to be 41, and then minus 32 over 41I. Just in case if you have a question, raising question in your mind, then how we left the previous one as a negative 3I, it's the same way I can write down as a real number, which will be equal 0 and then minus 3I. Yeah, same way. Okay, let me see. Let's do one more, 21. Let's do one more. 21, 1 plus 9I, 1 plus I. Okay, so from here, 1 plus 9I over 1 plus I. Every time we see I in denominator, then if we have only one I by itself, then we multiply by I in denominator, I in numerator. This way we get rid of it because I times I is I squared, and which is equal -1, and we are done. But when we have attached some other number, like here we have 1 plus I, to get rid of it, we are going to multiply by the same expression with -1, 1 minus I. Okay? So that's exactly what we are going to do here. It's going to be 1 minus I (1 plus I). Okay? So what do we get from here? We are going to get here going to be 1 squared is 1, 1 squared minus I squared, right? This is this formula. And on the top where we need to multiply in numerator, we need to do multiplication. Let's start. 1 times 1, 1 times I. It's going to be 1 plus I. And then 9I times I, it's 9I times 1, it's going to be 9I. And 9I times I, it's going to be plus 9I squared. Okay? And we are getting here in denominator 1 minus I squared. In numerator, we are getting 1, I and 9I. It's going to be plus 10I. And 9I squared, it's going to be -9, right? Because I squared is -1. So, and we are getting -8 plus 10I, and in denominator 1 minus A squared. So that's going to be equal -8 plus 10I, and I squared is -1, so it's going to be plus 1, right? And we are getting -8 plus 10I divided by 2, which means -8 by 2 plus 10 over 2I. And result is -4 plus 5I. (22) 3 plus 24I over -8I. So we have imaginary number in denominator. So what do we have to do? We have to figure out how to get rid of imaginary number, right? The only way to do it, multiply by itself. Let's see. 3 plus 24I over -8I, and I am going to multiply by I, and multiply here also by I. So I'm going to get, let's distribute, it's going to be 3I, and then plus 24I squared. And at the bottom I will get -8I squared. Okay, 3I. Since I squared is -1, it's going to be -24, right? And here also I have I squared, -1 with negative, it's going to be +8. Let me clean this positive. So now I'm going to divide a common denominator, which is going to be 3 over 8I minus 3. Or we can write down -3, so will be in the format of complex numbers, -3 plus 3 over 8I. Next, let me see. let's do this one. 23 and we get square root of 5 plus 3i square root of 5 minus 3i. Does it remind you formula? A plus b, a minus b. And that is equal, where is it? Let me bring it down. That is equal a squared minus b squared, yes? Here we have. So this is going to be equal square root 5 squared minus 3i squared, which means 5, right? Minus 3 squared is 9 and I squared. So final result is, I'm going to put first, it's going to be 5 and then I squared, it's plus minus 1. With this minus, it's going to be plus 9. And it's equal 14. Okay, I'm done. Hopefully this was helpful for you. I solved a bunch of problems. And I'll see you in next video. Okie dokie.